In this video, we are going to cover the double data type. We will begin by discussing the said data type in general. Then we will learn how to declare and assign values to double variables. And finally, we will cover floating point arithmetic. The double data type is a numeric data type. That is, it can store numbers. However, unlike integers, double variables are capable of storing a value with fractional components. Numbers with fractional components are also called floating point numbers. This means that integers are some sort of subset of floating point numbers, so it is possible to store integers on a double variable. Now, let's deal with the declaration. To declare a double variable, first type in the data type and then the name of the variable, followed by a semicolon. Here is an example. We put in the data type, which is double, the name of the variable, and a semicolon to end the programming statement. To assign an initial value, we simply add an equal sign and the value we would like the variable to have. Here is an example. We use the equal sign and then assign the variable with a value of -1.0. Just like integers, the default value of a double is 0. It doesn't matter if the number is 0, 0.0, or 0.00, and so on. All of these would be treated as the same number. If no value is specified upon declaration, this default value is used. We can assign a new value to a variable any number of times after the declaration. It is basically the same as the declaration with initial value, but this time the data type no longer needs to be specified. Here's an example. First, we assign the variable with an initial value of -1. Then we again assign it with a value of 0. Now let us move on to floating point arithmetic. As we can see on this slide, floating point arithmetic is basically the same as integer arithmetic. We have the operations and the MDAS rule, which can be bypassed using parentheses. Here is an example. It's pretty much the same as integer arithmetic. In fact, we can add double and integer values together. They are both of numeric type, so usually we would not experience any problems with them while working with arithmetic operations. Here is another example. This time we use parentheses. Notice a difference in the results between the two statements. The difference is caused by the use of the additional parentheses. They bypass the MDAS rule. You might be wondering whether you should use an integer or double in your computer programs. Doubles are normally capable of storing integers. On the other hand, storing a double value on an integer will result in the loss of the fractional component of a number. As a rule of thumb, if you are unsure which data type to use double. Here is an example of such a situation. You can see here that the result of the calculation would be incorrect. The value of pi is stored in an integer, and this resulted to the number being reduced to 3. With this error, all the calculations that would follow would be incorrect as well. Here is another example. This time we now have the variable named pi as a variable of type double. Our radius is 1, so the resulting value for the area would also be equal to pi. If you will have a radius that would have a fractional component, then you would need to change its type to double as well. To recap, we covered the double data type. We also learned how to declare a variable of type double and how to assign a new value to it. We also covered floating point arithmetic and some rules regarding the usage of integers and doubles.